All right, let's jump right into something pretty wild today. We're going to look at what happens when you take 1 full kilogram of pure sodium metal and just toss it into a lake. Sounds crazy, right? Let's get into it.
So yeah, that's the big question here. You might remember from chemistry class that sodium and water, they don't exactly get along. But a whole kilogram, that takes things to a completely different level. And the result? Well, it's chaotic for sure, but it's also surprisingly complex.
Okay, and right off the bat, we have to say this, and I mean it. Please, please do not try this at home. The people who did this took massive safety precautions. This is 100% a watch, don't do kind of thing. We're showing you this for you.
So before we get to all the fireworks, let's actually meet the star of our show, sodium. Now, yeah, it's a metal, but trust me, it's probably not like any metal you've ever seen before. You know, when you think metal, you're probably picturing something like iron, right? Hard, dense, super strong. Well, sodium is basically the opposite of all that. It's incredibly soft, it's super light, and as we're about to see, it is highly reactive.
And this is where it gets really weird. All of these properties, they kind of scream instability. Like, it has to be stored completely submerged in oil. Why? Because it is just dying to react with any little bit of moisture or oxygen in the air. And get this, it's so soft, you can literally cut it with a regular knife. When you do, you see this amazing bright shine for about a second before it just instantly gets dull.
And that dulling, that's the reactivity in action. That tarnish is the sodium atoms grabbing onto oxygen from the air. This is a metal that just cannot be left alone. And that's a huge clue for the absolute chaos that's about to happen when it finally meets a whole lake's worth of water. All right, so we know our element. Now let's get to the setup for this whole thing. This wasn't just some guy chucking it into water, no. There was a really careful procedure here, all designed to be as safe as you can possibly be when you're about to cause a massive chemical explosion.
So here's what they did. They packed that whole kilo of sodium into a plastic bag, and then they poked holes in it so the water could get in and kick things off. But look at step 3, protective gloves and a helmet. A helmet. That just tells you how much power they were expecting to unleash.
Okay, here we go. The package is thrown. It hits the water. And this is where it gets really interesting, because it did not happen the way you'd think.
Think about this. For about 10 long seconds, nothing. Just silence. It's kind of creepy, actually. Then pop. A single small blast. But right after that, all bets are off. It just erupts into this non-stop violent barrage of explosions. So what's with that delay?
Well, the most likely reason is the very thing that was keeping it safe in the first place. The oil. Remember, it's stored in oil. That protective coating had to wash away first before the water could actually get to the sodium. Once that oil was gone, boom.
And the person who did this described it perfectly. They said it was like Diwali firecrackers. It wasn't just one big explosion. It was this rapid-fire series of bangs, one after the other, just hammering away.
So, we've seen the spectacular what, right? But now for the really cool part, the scientific why. What is actually going on at a chemical level to create that kind of crazy, sustained explosion?
It all starts with a simple concept. This is an exothermic reaction. Now, that's just a fancy way of saying that when sodium and water get together, they release a ton of energy. And that energy comes out as heat, intense heat. And that heat, well, that's the key to everything that happens next.
Okay, so here's the play-by-play of the chain reaction. Step 1, the sodium hits the water and it gets hot, really hot. Step 2, it gets so hot that the solid sodium actually melts into a liquid. Now here's the kicker. Step 3, that molten metal spreads out, creating way more surface area, which makes the reaction go even faster, which creates even more heat. You see where this is going? This whole thing creates a super flammable hydrogen gas, and all that heat ignites it. That's your explosion.
So yeah, that's the crucial point. It's a runaway feedback loop. The reaction literally feeds itself. It gets hotter, it gets faster, it melts, it exposes more surface area until it just can't contain itself anymore and detonates, over and over again.
And that just leaves you with this one thought, right? Sodium is everywhere. It's literally in the salt on your kitchen table. But in its pure form, it's hiding all this incredible explosive power. So it makes you wonder, if an element this common can do that, what are the crazy secrets that are just waiting for us in the periodic table? Pretty cool to think about.